This is the grade 12 Unit 2 MHF4U seminar on graphs of logarithmic functions. So we are going to be comparing logarithmic functions with exponential functions. So the formula for both functions, y is equal to a to the power of x, is the formula for exponential functions. For logarithmic functions, it's y is equal to log x to the base of a. Now the domain for exponential functions, well, before we get to that, exponential functions and logarithmic functions have a relationship. They are the inverse of each other. So that means they are reflections of each other along the line y is equal to x. And because they possess an inverse relationship, you'll notice that the domain, for example, for exponential functions is x belongs to real numbers. That is related to, if we inverse that, that's equivalent to the range of logarithmic functions. Y belongs to real numbers. The domain for logarithmic functions, x has to be greater than 0. That's why we say that logarithmic functions can't really have negative values of x. And that is related to the range for exponential functions. Y has to be greater than 0. Because you'll notice that even if my my values are, for example, your base to the power of negative exponents, negative exponents are usually fractions, and you'll get closer and closer. You'll get closer and closer to the value of 0. So with exponential functions, you'll get closer and closer to the the x-axis, but you won't actually touch it. Same thing for logarithmic functions. We are going to get closer and closer to the y-axis, but you're not going to actually touch the y-axis. So we're going to become closer and closer and closer to it, but you'll never touch it. For exponential functions, you get closer and closer to the x-axis, but you're not going to actually touch it. Now you'll also notice with your intercepts, for exponential functions, my intercept is along the y-axis. We have the point when x is equal to 0, y is equal to 1. If we change the x and y coordinates, just like when we're finding the inverse of a function, we switch the x and y in the equation. Well, if we switch x and y and we get 1, 0, and that becomes my intercept for my logarithmic function. So there is a very clear relationship here between exponential functions and logarithmic functions. This corresponds to any type of base. For the graph that I have on the board, my base is 2 to the power of x. And that is equivalent to the logarithmic function log x with base 2. Okay, we're going to talk about how to actually come up with those equations in a little bit. There's another part 2 of this table. So you should note the increasing intervals and the decreasing intervals. Just want to change one thing here. What does the word asymptote mean? Do you guys remember from last year the word asymptote? So this is a very important concept, the word asymptote. That means when your graph is approaching a line but will never ever touch it. So the asymptote for exponential functions, we already talked about, is the x-axis. Because the graph is going to continue and get closer and closer and closer to the x-axis, but it's never going to touch it. So my asymptote is the x-axis. Now for the inverse function, your asymptote is going to, your logarithmic function graph is going to get closer and closer and closer to the y-axis, but it's not going to actually touch the y-axis. So my asymptote over there is going to be the y-axis. Both functions are continuous, both are smooth. You'll notice curvature to your graph. When we're doing regression, you're going to notice that your regression values have everything to do with how flat the graph is, how much curve there is to the graph, just like we had slopes before, but we'll talk about that in a little bit. Now there's going to be some notes, so don't worry, I'm going to put a video up today if you don't have a chance to copy this. I just want to move on a little bit. We're going to talk about, now with that inverse relationship, we're going to talk about how to come up with graphs, how to come up with table of values, and also how to come up with equations. So we're going to address the graph of y is equal to log to the base of 0.5 in a second. But let's start off with the graph that we were just looking at, which is y is equal to log x with the base of 2. So I want to highlight this equation. First thing we have to do with inverse functions, copy the steps, copy the equation. So we're going to set the equation equal to y. So y is equal to log x to the base 2. You set it equal to y. Then we swap the x and the y variables. So instead of y, we now replace that with an x. Instead of x, we replace that with a y. And then we utilize the definition of the logarithm in order to figure out the final step. So I know if something is in the form log base of y is equal to x, that is going to translate to b to the power of x is going to be equal to y. So that's how we go from x is equal to log y to the base 2. By applying that rule, we can translate it to y is equal to my base, which is 2, to the power of x. So that's how we come up with the equations. Everyone understand that? Because sometimes, maybe not in this unit, but especially in Unit 3, you're going to have to manipulate the equations to find the inverse. And you have to use logarithmic rules in order to do that. Okay, now we're going to talk about how to actually draw a graph, come up with the table of values. So, see, we have y is equal to 0.5x, and y is equal to log x to the base of 0.5. Let's start with that, okay? So, let's move to another slide. We have y is equal to log of x with my base of 1/2. We can easily see that that is equivalent by applying my logarithmic rules, or my inverse operation, to x is equal to 1/2 to the power of y. Now this is really important. Like here we have the final product, but how do we get that final product? Usually you're used to, when you're doing linear functions, quadratic functions, when you had to generate a table of values, you would find all your x values and plug it into your y, right? Now, with logarithmic functions, in order to graph them, we're doing the opposite. So let's go ahead and make a table of values, first of all. So the first thing I'm going to do is plug in my y values. Y is equal to -2. Y is equal to -1. Y is equal to 0. Y is equal to 1. And y is equal to +2. So we're doing the opposite of what we usually do. Why? Because our equation is in the form x is equal to 1/2 y. We translated our logarithmic equation into exponential form. When we did that, we got an equation that said x is equal to. So what I'm going to do is go ahead and plug in